I'm going to go ahead and go over problem number 3A from your Q3Day39 homework, the 6.2b volumes by cross-section worksheet. And what I really want to go over is the graphing, especially the three-dimensional graphs for the volume. And I guess I want to clarify some stuff that I said in class about the X, Y, Z coordinate plane. I'm still noticing some confusions as far as visualizing some of these graphs. So I'm going to start off by showing what Desmos shows when you go ahead and graph y equals e to the negative 2x, y equals 0, x equals 0, and x equals the natural log of 5. This is what Desmos has. In pinkish is y equals e to the negative 2x. Blue we have y equals 0, which is pretty much the x-axis. In green is x equals 0, which is pretty much the y-axis. And in orange we have x equals the natural log of 5. So we're focusing on this region right here. So what I'm going to do is I'm going to replicate this along with the three-dimensional figure on the XYZ coordinate plane. So on the left, what I have here is pretty much me replicating what I got from Desmos. And then, so here you have x equals 0, x equals the natural log of 5. Let me label that. Here we have y equals 0, and that's in blue. And then in pink is y equals e to the negative 2x. And the region is pretty much this yellow shaded region that I've highlighted. Now, what I want to do is I want to get you guys to understand how it would look as a solid. So here is my solid that I'm going to go ahead and get, because I know that my cross sections are squares, and these squares have congruent sides. So there you have the 4 congruent sides for the square. And notice that what pretty much happened is you kind of have to visualize this. You have to use your imagination, and what I did was this two-dimensional graph, this two-dimensional region that's bounded by the functions, the 4 functions, was pretty much laid flat. X, Y coordinate plane was kind of laid flat, and you have this z-axis cutting through it. Okay, and you have to visualize these cross sections, these square cross sections that are pretty much popping out in 3 dimensions. Okay, so you have to try to visualize that. So if we had an infinite amount of these cross sections that are squares that were being stacked, we have this pretty much 3-dimensional solid. Okay. So these 3-dimensional solids, if I take any square in it, notice that the base will always be bounded by the pink y equals e to the negative 2x, and the blue y equals 0 function. Okay? So let me take this space here. If I were to make a square, with using this base here, it would go up to about here. Again, a lot of this is using your imagination and seeing what our square looks like. Okay? No matter where we place our square, it will always be bounded by the top y equals e to the negative 2x function and y equals 0 function. Okay? And it's pretty much, you're putting these squares on this. Remember I told you that you want to think of this as your foundation. So you have laid your squares on your foundation, but if you want to think of them in 2D, it's top minus bottom, and these squares are popping out at you. Okay, so these squares are popping out at you. So this is the base of the square, and they're popping out at you to make this three-dimensional solid. So if we know that the area for a square is pretty much one of its side squares, so area for a square area is equal to one of the sides squared. We know this much. We know that volume with by cross sections, the formula for volume found by cross sections is V equals the integral from a to b of a to x dx. And I'm telling you that one of the sides or the base is pretty much found by the top function minus the bottom function. So we know that a side for this diagram, S equals the top function e to the negative 2x minus the bottom function 0. Then all I'm going to do is I'm going to plug this here to find the volume. So basically what I have is that volume, my setup is volume is equal to the integral. Now notice that it goes from 0 to ln of 5. And I know that my function for the area is one of the sides squared, so it's something squared. And I know that that something is one of the sides, and I just determined that one of the sides is e to the negative 2x minus 0. That's pretty much your setup. So to answer problem number 3A, we pretty much have e to the negative 2x squared, I forgot the x, with respect to x. So the integral from 0 to the natural log of 5 of e to the negative 2x squared with respect to x. Now what I want you guys to do, my challenge to you guys is integrate this without the graphing calculator. You should be able to do this you should be able to calculate the integral without the graphing calculator. So you guys finish this. My intention with this video was just to help you visualize the solid, okay? And how you can use the two-dimensional XY coordinate plane to get your setup. And that'll conclude the video.